Chapter 7, Lesson 5, Exponential Functions. So the first thing we're going to do with exponential functions in this section is graph them. So we're going to do that by using our XY table. And remember that for our XY table, under our X's, we use -1, 0, and 1. We're also going to find the y-intercept, and that will be our middle point. So when we find our X is 0, remember for our y-intercept, it's 0, a number. And so that will be our y-intercept. Remember, the domain is the X's and the range is the Y's. The last thing that's new that we're going to talk about is a horizontal asymptote. So a horizontal asymptote is a line that a graph approaches but does not cross. So we could have like a horizontal asymptote here, and then our exponential function will curve and it'll get really close to, but it will never cross the y equals whatever the horizontal asymptote is. So it's going to be y equals a number because it's a horizontal. Now, we're going to be asking ourselves, is something a horizontal growth if it's going up from left to right, or exponential decay if it's going down from left to right? So those are all things we're going to be discussing. Okay, so the first one just starts with graphing the function, finding the y-intercept, and stating the domain and range. So we're using -1, 0, and 1. And the first one is 1/10 to the -1 power. And so we know that if anything's to the negative power, we have to flip it. And so it's going to become 10, or 10 over 1. The next one is 1/10 to the 0. And from our last section, we know that anything to the 0 power is 1. And the last one is 1/10 to the first power, which is 1/10. So we have -1, 2, 4, 6, 8, 10. 0, 1, and 1, 1/10. So this one is exponential decay. And what it's actually going to do is get really close to the x-axis, but never cross it. So if we were talking about the horizontal asymptote, I would say it's y equals 0. Now my domains, it's going forever to the right and forever to the left, so that's all x's. And my range matches my horizontal asymptote, except for it has a symbol, so y's are all greater than or equal to 0. Number 2 is -1, 0, and 1. So 3 to the negative first power needs to be flipped, so it becomes 1/3. 3 to the 0 is 1, and 3 to the first is 3. So -1, 1/3, 0, 1, and 1, 3. And it's an exponential curve. Domain is all x's, and ranges are y's greater than or equal to 0. And the last one, 1/4 to the -1 gets flipped, so it's 4. 1/4 to the first, or to the 0 is 1, and 1/4 to the first is 1/4. So -1, 4, 0, 1, and 1, 1/4. Domain is all x's, range is y's greater than or equal to 0. All right, so we've talked about linear and exponential before, and what the new thing is we're going to add is quadratics. So go ahead and pause and take these notes. So when we're looking at these, one of the things that we could do was to graph these points on our graphing calculators. So we'll do that, but we're also going to do it by doing the subtractions, which is what the last slide was telling us. So this last slide was telling us that if we do subtraction on the y values, and the first time we do the subtraction, they are equal in value, that it is going to show us a linear graph when we graph it on our calculator. So we'll try that first. So we're going to do 480 minus 120, which is 360. And then 120 minus 30, which is 90. And 30 minus 7.5, which is 22.5. So those first time we did the subtraction, they're not the same. So this does not show linear data. So we do it again. 360 minus 90 is 270. And 90 minus 22.5 is 67.5. And those are not the same, so it's not quadratic. So then we know that this one shows exponential behavior. So if we go to my TI Connect and I think I have to do like Control K. I don't know if that is showing up. I don't think so. I think it's still just showing that screen. No, I think I'm doing the whole screen. I don't know. Hopefully you can see this. Now I'm questioning on if the last one I did, you could see it also. Okay, let's select all, delete. Okay, so what I'm going to do is I'm going to put into my stat, edit. If there's anything in my L1, L2, I'm going to clear them out. So it looks like this. Okay, now I'm going to put the data from the PowerPoint into it. So my X's are 2, 5, 8, and 11. And my Y's are 480, 120, 30, 7.5. So now it should look like this. I'm going to go to my window, and I want the data for the X's to be between 0 to 15. And my Y values are between 0 and 500. Go to my Y equals, clear out anything that's in there, and make sure that my plotting app is turned on, and hit graph. And what you can see from this is it is a curved exponential shaped graph. So let's do the subtraction on these. We get 7, 7, 7, and those are all the same. So this one should look linear when I put it in. So I'm going to go back to my stat edit, clear out what I have. For my X's, I'm putting in 21, 18, 15, 12. And for my Y's, 30, 23, 16, 9. Go to my window, and my X's are between 10 to 30 or 10 to 25. And my Y's are between 0 to 35 or 0 to 40. What is it saying? Oh, duh. That I didn't change that. Okay. There. So it should look like that. Okay. And when I graph it, I might have typed something in wrong because I got this one random point down here, but it does look linear. So I must have typed in one point wrong. Oh, it's supposed to be 15, 16, not 15, 9. Okay, there we go. Now I got it working. There, and so it is linear. So you can check them in your calculator to make sure, but you should do the subtractions on them to figure out if it's exponential, linear, or quadratic. So now we have this word problems. Ms. Klumper told her English class that each week students tend to forget 1/6 of the vocabulary that words they learned the previous week. If a student learned 60 words, the number of words remembered. So if they're forgetting 1/6, that means they're remembering 5/6 of them. So that's why they put the 5/6 there. And X is the number of weeks. How many words will the student remember after 3 weeks? So we have 60 times 5/6 to the third power. Which is about 34 words, because I got 34.7, but I can't put 0.7 of a word, so I'm just going to put it as 34. Suppose a certain cell reproduces itself in 4 hours. If a lab researcher begins with 50 cells, how many cells will there be after 1 day, 2 days, and 3 days? So 1 day is, 24 hours, 48 and 72. And X is my number of times it reproduces. So if it's every 4 hours, it would do it 6 times in 1 day, 12 times, and 18 times. So we're going to do 50 times 2 to the 6th, 3,200. 50 times 2 to the 12th, 204,800, and 50 times 2 to the 18th, 13107,200. 13,107,200.